Good morning, everyone. We are the Group 2, and this is our presentation for the assignment for surveying and transportation.
So this sample problems is categorized by field measurements, which is under in surveying problem solving. So as first, the first problem is we have the given of coordinates of point L that has 2,000 feet and 5,000 feet, and the coordinates of point P is 1,400 feet and 5,500 feet. So the bearing of LM is equals to 85 degrees and 25 minutes and 39 seconds southwest. So the distance of LM is 276.98 feet. So this is the free body diagram of the problem. So this solution is we find the azimuth first of LM. So the azimuth LM is equals to 85 degrees 25 minutes and 39 seconds plus 180 degrees. So which is bearing plus 180 degrees. So it is equals to 265 degrees 25 minutes and 39 seconds. So that is the azimuth LM. Next is we find the coordinates of point M. So the coordinates of the x-coordinate of point M is equals to the x-coordinate of point L plus the distance of LM times the sine of azimuth LM. It is equals to 2,000 feet plus 276.98 feet times sine of 265 degrees 25 minutes and 39 seconds. So it is equals to 1,723.90 feet. The y coordinates of point M is equals to y coordinates of point L plus the distance of LM times the cosine of azimuth LM. It is equals to 5,000 feet plus 276.98 feet times cosine of 265 degrees 35 minutes and 39 seconds. So the y coordinates of point M is equals to 4,977.92 feet. Next is we find the tangent of the angle, which is the formula is the coordinates of point P minus the coordinates of point M divided by the y coordinates of point P minus y coordinates of point M. So it is equals to 1,400 feet minus 1,723.90 feet divided by 5,500 feet minus 4,977.98 feet. So the tangent theta is equals to negative 0.620403. So since the theta is an angle and not an azimuth, the sign of the tangent theta can be taken as positive. So therefore, the theta is equals to arctan times 0.620403 is equals to 31 degrees 48 minutes and 56 seconds. So therefore, the bearing of MP is equals to 31 degrees 48 minutes and 56 seconds southeast. So for the next problem, which is under also in field measurement. So the problem is a line of PQ is measured and recorded as a slope distance of 257.56 feet with a slope of 4 degrees. So if the actual slope of the line is 3 degrees, so we find the error, which is the incorrect slope is introduced in the problem. So the solution is the horizontal distance, which is HD, is given by HD is equals SD, which is slope distance times cosine beta. Okay, so in this solution, it is categorized by the true and the incorrect horizontal distance. So in horizontal distance, true is equals to 257.56 feet times the cosine of 3 of 3 degrees, which is the true slope line of a problem. So the result is 257.21 feet. And in under of incorrect horizontal distance, it is equals to 257.56 feet times the cosine of 4 degrees. So the answer is 256.93 feet. So let us find the error. So the error is determined from the difference in these values. So the formula is horizontal distance error is equals to horizontal distance true minus horizontal distance incorrect. It is equals to 257.21 feet minus 256.93 feet. So our values of horizontal distance is equals to 0.28 feet. So that's all.
Good day, guys. I am Jimwell Arbusbus, and this was the problem that I was assigned. So, first problem: a symmetrical vertical summit curve has a tangent of positive 4% and a negative 2%, respectively. The allowable rate of change of grade is 0.3% per meter station. Stationing and elevation of PVT is at 10 plus 0.20 and 142.63 meters respectively. So there are three conditions you need to calculate or compute. So first condition, for letter A, calculate the length of the curve. Letter B, so compute the distance of the highest point of the curve from the PVC. And lastly, or letter C, compute the elevation of the highest point of the curve. Solution. So as you can see in the slide, it is a vertical summit curve which has a back tangent or the G1 which is equal to positive 4% and a forward tangent or the G2 which is equal to negative 2%. So the PVT has a station of 10 plus 0.20 and it has an elevation of 142.63 meters. In this slide, so you need to get the first condition or the calculate the letter A or the length of the curve. So we are using the rate of change or R, which is equal to R is equal to G sub 1 minus G sub 2 all over N. So ang missing lang dre is ang station which is ang N. So natay R, G1 o G2, so makuha din nato si N. So ang R is equal to 0.3, G sub 1 is 4%, then G2 is negative 2 all over N. So by calculating, so N is equals to 20 stations. So makuha na tong L. Ang L is equals to N times 20 meter per station. So constant ang 20 meter basta vertical curves. So substitute N to 20. So L is equals to 20 times 20 which is equal to 400 meters. So mo na ang length of the curve. So next is the letter B or the second condition. So stationing of the highest point on the curve. So as you can see in the illustration, nag-assume ta ang highest point is near to the PVT. So S is equal to, natin formula na S is equal to G sub 1 times L which is the length of the curve which is nakuha na to ganina sa letter A nga 400 meters all over G sub 1 minus G sub 2. So na natin value na tanan. So diretso lang na to compute ang S. So makuha na to ang 266.667 meters from the PVC ang S. So by nakuha na nimo ang S, so maka-compute na ka sa highest point or the station of the highest point. So, ang pagkuha sa station sa highest point is station sa PVT minus sa L or the length of the curve plus the S. So natay given nga station sa PVT which is 10 plus 0, 20. Then ang length sa curve is 400. Then ang S is 266.667. So we conclude that the station highest point or the station of the highest point is station 09 plus 886.667. So in this slide, so last condition, so letter C, which is we need to find the elevation of the highest point of the curve. So before that, we need to get the h or identify unsang value sa h. So h, natay formula nga ang h is equals to length of the curve all over 8 times the g sub 1 minus g sub 2. So na natin mga value ng L, g sub 1 o g sub 2. So substitute na lang ka. So 400 divided by 8 times 0.04 which is the g1, g sub 1 plus 0.02 or the g sub 2. So by that, makuha na to ang h na equal to 3 meters. So natay zoom in diri para makita nato jud ang elevation of highest point. So natay value na 133.33 meters or the base which is gikuha na pamagi sa L minus S or the length of the curve minus atong S. So 400 minus 266.667 is equal to 133.33 meters. So natay G sub 2 na negative 2%. So magamit ana unya. Then ang y nga unknown, so by ratio and proportion makuha na to ang y which is y all over 133.33 squared is equal to 3 over 200 squared. So gamitan og calculator, so y is equal to 1.333 meters. So nanatay y, so ready na ta magkuha sa elevation of the highest point. So natin formula or ang pagkuha sa elevation of highest point is equal to elevation sa PVT which is given na naa sa illustration na 142.63 meters. Then plus the 133.33 or the L minus S and i-times sa G2 G sub 2 which is equal to 0.02 minus Vy nga imong nakuha kanina sa ratio and proportion. So naka-given na 1.333. So yes, makuha na nato ang elevation of the highest point which is equal to 143.964 meters. Second problem. So a large log become visible to a driver at a distance of 140 meters. Assume the driver's perception reaction time of 1.75 seconds, an initial speed of 82 kilometers per hour, and the coefficient of friction is 0.5. Determine whether the driver would hit the log if, so nanaputay tulo ka condition. So letter A, if the roadway grade is 8%. So maigo ba sa driver ang lag kung roadway grade is 8%? And letter B, the roadway grade is level, so straight lang siya. So the last is the roadway grade is negative 12%. So mao nang mga condition. So solution. So nata illustration nga nagpakita natin car nga na siya initial speed na 82 kilometers per hour or the V. Then ang distance nga na visible sa driver ang log is 140 meters. So SSD is equals to braking reaction distance plus the braking distance. So in this slide, so solution. So first condition, roadway grade daw is 8%. So natay SSD is equals to VT, which is ang VT is the braking reaction distance plus the braking distance. So ang formula sa braking distance is V squared over 2G or ang G is 9.81 times the F or the coefficient coefficient of friction. So plus minus G, which is ang G is ang grade. So, um, substitute the formula, substitute ang mga values sa formula. So, natay V na 82. So, as you can observe na natay 3.6. So, gi-divide ang initial speed or ang 82 sa 3.6 para ma-convert ang kph into meter per second. So, natay 82 over 3.6 times 1.75 plus 82 over 3.6 raised to 2 all over 2 times 9.81 times 0.5 plus 0.08, which is ang grade niya 8% ang 0.08. So, um, makakuha ta og value na 85.454 meters, which is ang SSD sa first condition. So, since ang SSD or ang 85.454 meters is less than siya sa 140 meters, so we can conclude or therefore the driver will not hit the log. So second condition, so roadway grade is level, so straight ra daw, wala siya grade. So again we are using the same formula. So nag-divide gyapon og 3.6. Pero wala lang kay mag-add sa grade kay or 1 man siya or level lang man siya. So again, the same 82 over 3.6 times 1.75 plus 82 over 3.6 raised to 2 all over 2 times 9.81 times ang coefficient of friction lang imong ma-add. So which yung ma-multiply, which is 0.5. So natay makuha na SSD na 92.749 meters. So again, ang SSD is less than 140 meters or the length sa nakita sa driver ang log or ang distance nga nakita sa driver ang log. So we can conclude that the driver will not hit the log kay mas dako man ang distance kaysa sa SSD, which is so last condition. So letter C, roadway grade is negative 12%. So again, we are using again the same formula. So substitute na lang. So 82 over 3.6 times 1.75 plus 82 over 3.6 raised to 2 all over 2 times 9.81 or the G times the 0.5 or the F or the coefficient of friction minus ang condition niya negative 12% ang grade. So negative 0.12. So SSD is equals to 109.450 meters. So kay mas since SSD again less than siya sa 140 meters, again I conclude that the driver will not hit the log. Thank you.
So, good day everyone. My name is Kenneth Levi Pasyente and I'll be discussing a problem for the topic passing sight distance. So, the problem is compute the passing sight distance for the following data. Speed of the passing car is equal to 90 kph. Speed of the overtaken vehicle is equal to 70 kph. Time of initial maneuver is equal to 4.3 seconds. Average acceleration is equal to 2.37 kph per second. Time passing vehicle occupies the left lane is equal to 10.4 seconds, and the distance between the passing vehicle at the end of its maneuver and the opposing vehicles is equal to 70 meters. So to solve for this problem, we first have to understand the formula for the passing sight distance, which is d1 plus d2 plus d3 plus d4, where d1 is equal to the distance traveled during the perception reaction time to point where the vehicle just enters the left lane. D2 is the distance traveled while passing the vehicle. Passing vehicle occupies the left lane. D3 is equal to the distance between the passing vehicle at the end of its maneuver and the opposing vehicle. And D4 is the distance traversed by an opposing vehicle for 2/3 of the time the passing vehicles occupies the left lane. It is usually 2/3 of D2. So the formula we use in solving the distance one is just quantity V minus M plus a times time 1 all over 2, all of this multiplied to time 1, where m is equal to 90 minus 20, 90 minus 70 is equal to 20 kph, v is equal to 90 kph, a is equal to 2.37 kilometers per kph per second, t1 is equal to 4.3 seconds. So substituting all the values we have, we get the distance 1, which is equal to 89.97 meters. D2 is, the formula for D2 is equal to V times time 2, where V is 90 kph, time 2 is 10.4 seconds. So multiplying 90 by 10.4, we get 260.0 meters. D3 is given, which is 70 meters, and D4 is just 2/3 of D2, which is 173.33. The formula for the passing side distance is just D1 plus D2 plus D3 plus D4, hence we get the value 593.030 meters. So for problem 2, what is the difference in elevation between A and B if in a two-peg test method of a dumpy level, the following observations were taken? So for the instrument setup near A, for rod reading A, we have 1.505 meters. For rod reading B, we have 2.054 meters. And for the instrument setup near B, we have 0.938 meters and 1.449 meters for B. So to solve this problem, you just have to draw a diagram in order to analyze the different heights of the observations taken from the two-peg test. So the formula and after observation, we have this equation 1.505 plus y is equal to 2.054 minus e. E is the distance from the horizontal line and the line of sight. So we have the equation 1, which is equal to y plus 1 is equal to 0.549. For the red reading on B, we have the equation y plus 0.938 minus e. This minus e because the line of sight is below the height of 0.938 meters. So y plus 0.938 minus e, which is equal to 1.449. So we have the equation to y minus e is equal to 0.511. So using the equations 1 and 2, we get the height y is equal to 0.53 and e is equal to 0.019 meters. So the distance, the difference in elevation between A and B is equal to 0.53 meters.
Good day, everyone. So, here is the problem for the embankment of the curve. A highway curve has a radius of 400 feet, is banked so that there will be no lateral pressure on the car's wheel at a speed of 48 kilometers per hour. What is the angle of elevation of the embankment? By applying this Newton's second law of motion in this embankment curve, we can get that the y-axis will be the weight and the x-axis will be the weight times the velocity squared over the gravity due to acceleration due to gravity times the radius. So here represents the figure of for the problem. So the radius, we must first convert the radius to feet to meters, the radius, and the velocity kilometer per hour to meter per second. So tangent theta is equivalent to the weight times the velocity squared over the acceleration due to gravity times the radius times the weight. So cancel out the weight, we can get then the tangent theta is velocity squared over the acceleration due to gravity and r. By substituting, we can get that the elevation of the embankment of the curve will be 8.45 degrees. So this will be the answer for this problem. Second problem will be the stiffness factor of the pavement. So the problem will be compute the modulus elasticity of the subgrade if the modulus elasticity of the pavement is 120 megapascal with a stiffness factor of 0.50. So we have the formula of the stiffness of the factor or stiffness factor of the pavement equivalent to ES stands for the elasticity of the subgrade, modulus elasticity of the subgrade equivalent or I mean all over the modulus elasticity of the pavement raised to one-third. So by substituting the formula and by manipulating, then we can get the elastic modulus or modulus elasticity of the subgrade equivalent to 15 megapascal.
Good day, everyone. Good day, ma'am. So, I have here a problem for simple curves and compound curve. One for simple curve and one for compound curve. So, first is for the simple curve. A simple curve connects two tangents AB and BC with bearings n 85 degrees 30 minutes north of east and 68 degrees 30 minutes south of east respectively. If the stationing of the vertex is 4 plus 360 and the 360.2 and the stationing of PC is 4 plus 288.4, determine the radius, external distance, the middle ordinate, the core distance, and then the length of curve. So, makita ninyo on the right side of the slide kay nakogihimo nga figure just to show you the or just to represent the problem, no? So una, we need to solve for the radius, and then since radius kailangan naman siya of value for the distance of t, kailangan pag yun nato isolve si I or the deflection angle. So since na may mga bearings nga gihatag, ato lang i-subtract, no, ang mga bearings sa 180. So 180 degrees minus 85 degrees 30 minutes minus 68 degrees 30 minutes, our deflection angle is 26 degrees. And then if you look at the stationing of PC and stationing of PI, makuha nato ang T kung ato silang i-minus, no? So diha nato makuha si T by simply subtracting them. So stationing of PI minus stationing of PC, ato makuha ang value ni T or the distance of the tangent, which is 71.8 meters. And then makuha na po dahil nato si radius. Ang kaning formula sa radius is actually from the formula sa T na r tangent I over 2. So i-manipulate lang ang equation and then gisubstitute ang values. Therefore, atong radius is 311 meters. Next, we are tasked to find the external distance and then follow lang yapon ta sa formula nga gi-provide, and then diri lang ta diretso sa simplified form, which is r times the quantity of 1 over cosine I over 2 minus 1. Substitute lang yapon ta sa values, then makuha na to si E, which is 8.181 meters. Next, ato dayong isolve si middle ordinate. The original formula for middle ordinate is m is equal to r minus r cosine of I over 2. Then gi-simplify, gi-factor out si r, we arrive to m is equal to r times the quantity of 1 minus cosine of I over 2. Then pang substitute lang yapon natong values, makuha na to si m, which is 7.971 meters. Next, that is followed by the core distance. So core distance, L or C, is equal to 2 times the radius times the sine of I over 2. So we simply substitute the values, makuha na to ang core distance nga 139.920 meters. And lastly, atong isolve si length of curve LC. So nagya po yung formula si length of curve, which is pi times the radius times the deflection angle all over 180 degrees. Dahil ipang input lang na itong values, makuha na to si length of curve which is equal to 141.127 meters. And that's it for the simple curve. Next, we have here a problem for compound curve. The common tangent AB of a compound curve is 76.42 meters with an azimuth of 268 degrees 30 minutes. The vertex V is being inaccessible. The azimuth of the tangents AV and AB was measured to be 247 degrees 50 minutes and 282 degrees 50 minutes respectively. If the stationing of A is 43 plus 10.46 and the degree of the first curve was fixed at 4 degrees based on the 20-meter chord, using chord basis, determine the stationing of PC, stationing of PCC, and the stationing of PT. So as you can see on the right side, nagyapon ko gihimo nga figure just to illustrate the problem, and ako pong gipangbutang diri ang mga given, no, on the lower left side of this slide. So first, we are tasked to find the stationing of PC. So gitagaan mas ta og stationing of A sa point A, pero gikan sa point A makuha lang nato si PC if we have the value of T1. So kailangan nato i-solve si T1. And how do we do that? We first need to solve for the radius. So in solving the radius, tagaan man ta og degree of curve. So gamiton lang nato ang formula for the chord basis, no? Using the chord basis, which is sine of d1 over 2 equal to 10 over r1. That is for the metric unit system. And then ato lang i-manipulate, then substitute the values. We get r1 is equal to 10 over sine of 4 over 2, and our radius is 286.537 meters. Now, si T, di po nato siya makuha kung wala tayo deflection angle I1. So, ato pong isolve si deflection angle I1, and I2 na po, kay gitagaan naman tag mga azimuths kaning sa AB ug sa AV, no? So, for the I1, ato lang i-minus si azimuth AB minus the azimuth AV. So, I1 is equal to 268 degrees 30 minutes minus 247 degrees 50 minutes. Therefore, our I1 is equal to 20 degrees 40 minutes. And our I2 is equal to azimuth VB minus azimuth AB. And substitute lang yapon natong values from the given as shown in this slide. Our I2 therefore is 14 degrees 20 minutes. So karon na naman tay value for the I1 and the R1, makuha na nato si T1. So in solving T1, we simply follow the formula R tangent of I over 2. So therefore our T1 is equal to 286.537 tangent of 20 degrees 40 minutes over 2. Our T1 therefore is equal to 52.245 meters. Makuha na dayon nato si stationing of PC, kaya na naman tayo given nga stationing of A na napod tayo na solve nga value for T1. Stationing of PC therefore is equal to 43 plus 10.46 minus 52.245. Hence, the value for stationing of PC is equal to 42.958.215. Next, isolve nato si stationing of PCC. So, si stationing of PCC is actually daghan siya pamaagi. No? We can solve for stationing of PCC from PC by adding the stationing of PC plus kaning L1 or stationing of PC plus 2T1. But since gamiton man gyapon nato si length of curve, gamiton na lang nato i-utilize nato yung formula since mao man po'y mas daghan og given, which is the I1 ug si D. So i-input lang nato sa formula ang values, makuha nato si LC1 is equal to 20 times 20 degrees 40 minutes all over 4 degrees. So LC1 therefore is equal to 103.333 meters. Makuha na dayon si stationing of PCC gikan sa PC. So stationing of PCC is equal to stationing of PC plus LC1, that is equal to 42 plus 958.215 plus 103.333. Therefore, the stationing of PCC is equal to 43 plus 61.548. Now, lastly, we're tasked to find the stationing of PT. So, this one is a little bit tricky, no? Kay daghan og pangitaon. But, if gikan sa PCC, masolve nato si PT by adding the stationing of PCC plus 2T2 or plus L2 or plus the length of curve 2. So, pwede na, akong gibuhat diri is I solve for the T2 kaya na may value for distance from A to B and then napot ay T1. So, ato lang i-minus si T1 from AB. Therefore, our T2 is equal to 76.42 meters minus 52.245 meters. Atong T2 therefore is equal to 24.175 meters. So, makuha na nato karon si radius. Gamiton lang yapon nato tong formula gamit nato sa part A, no, which is T2 is equal to R tangent of I over 2, but this time we will use the deflection angle of the second curve. Then manipulate lang yapon ang formula para makuha si R2, then substitute. Our R2 therefore is equal to 192.264 meters. And then using chord basis, same lang yapon sa first nga gipangayo, no. So but this time atong pangitawon is ang degree of curve para makuha na to or mag-utilize na to ang formula for the length of curve for the second curve. So the formula for the chord basis is sine of d2 over 2 is equal to 10 over the radius, second radius. Then i-manipulate lang na to ang formula, then i-substitute para makuha si d2. Then d2 therefore is equal to 2 times the arc sine of 10 over 192.264. Therefore, our second degree of, or the degree of curve of the second curve is 5 degrees 57 minutes and 46.1 seconds. So, makompute na dayon nato largo si length of curve using the formula. Now, 20 times I over D. Then, atong gamiton nga I is the I2, I sub 2. So, length of curve 2 is equal to 20 times 14 degrees 20 minutes all over 5 degrees 57 minutes and 46.1 seconds. So, ang atong length of curve, second length of curve is 48.076 meters. So, makuha na dayon nato si stationing PT. Si stationing PT, if task or ang gipangayo is stationing of PT gikan sa PC, stationing PC, ang ato lang buhaton is we add stationing PC plus the length of curve 1 plus the length of curve 2. Pero pwede naman gyapon nato makuha si stationing PT by adding stationing PCC plus the length of curve 2. So, mao na itong buhaton. Therefore, ang stationing of PT is equal to 43 plus 61.548 plus 48.076. Therefore, our stationing PT is equal to 43 plus 109.333. 624. So that's it for my part. Thank you and have a good day ahead. Thank you for listening, everyone. That's the end of our presentation. Have a nice day ahead. Thank you and God bless.